So very good morning students. So today's experiment we are going to discuss is about BJT, bipolar junction transistor, and this transistor can be configured into three different configuration. One is called common base, common emitter and common collector. With respect to your lab session, we will deal with common emitter and common base. So today let us discuss with common emitter. Okay, so common emitter configuration we will see. So before going into common emitter, let us see what is BJT is. So BJT is nothing but two diodes connected back to back, which means, see, you have, when you have N and P, this junction forms a diode, a PN diode. Similarly, this is again P and N, this is a junction, again this is a diode. So you can see here one N and P, another one is P and N. So it is back to back connected. So when you connect two diodes back to back, we get a transistor. See, everything when we see with respect to invention, they are going in step by step. First they started with diode, then they connecting two diodes back to back. Okay, and this is the first active device. Till this there was no active device. So invention of transistor started its career of active devices. So I have already told what is active, what is passive. When the flow of electron is controlled by its internal behavior itself, we call it as passive device. Active device, the flow of electron is controlled by external electric field, then you call it as active device. See, here you have a person called base. Okay, so from emitter to collector there will be flow, and this emitter to collector flow is controlled by this base. So flow of electron is controlled by external field, so this device is called as active device. I repeat, from the emitter to collector there will be a flow. See, emitter is nothing but higher potential with respect to collector, and the flow of electron is in reverse direction. We say from higher potential to lower potential, but flow of electron is from negative to positive. So that is why arrowhead is marked in this direction. There are two types. One we call it as NPN, another one is called as PNP. How to identify the differences? Pointing inwards. It is easy way. See, PNP. In PNP, pointing inwards, whereas in NPN, not pointing inwards, which means the arrowhead should not point inwards, it should point outwards. So that is what we have taken here also, NPN. Okay, in NPN transistor it is not pointing inwards, which is pointing outward. Okay, now the center portion is, here we have taken as P type. Okay, so from here we will try to control the flow of holes, and such that this will become totally N. See, if I inject N here, it will become totally N, then there will be flow of electron. So this flow of electron will start only if there is some base current. Only if there is base current, then this flow of electron will be there. See, base current is nothing but, you say, electron. So you are pumping electron inside. When you pump electron in the P, they become minority charge carriers. Once this N is brought here in the P layer, then there is all are electrons, so they will start flow. Okay, this is the logic behind your BJT. I think all this you might have studied in your theory. That is what is, why you called bipolar is, when you say bipolar, there are two type of transistor. So one is for holes movement, another one is for electron movement. So bipolar, both type of charges are possible. Okay, when you say it is P, then you say it is electron. When it is N, you say it is holes. So both is possible. So that is why the name it is given as bipolar. Okay, there is some more device called unipolar also, whereas this is bipolar device. So today's class we are going to see about common emitter configuration, which means there are three terminals. See, here you have emitter, base and collector. Among these three, we will combine two terminal to form input and output. See, for example, I can draw like this: emitter and base can be connected to input. Similarly, base and collector can be connected to output. See, here when you do this type of configuration, one terminal is kept common. Okay, so that is why the word is given as common. So in common emitter configuration, what you have to do, emitter should be in common with both input as well as output. So what you will do, emitter with the base you give it as input, emitter with the collector you will say it as output. So emitter is common between your input as well as output. So that is why we call it as common emitter configuration. Okay, so you can see here all this is here I told no, it is NPN, not pointing inward. So they have put an arrowhead outside. Next diagram when you see they have drawn for PNP, so pointing inwards, so arrow has to come inward direction. Okay, so next three terminals and all we know what is emitter, what is base and collector. Under manufacturing, this base should be thin compared to emitter and collector. Just for understanding, here they have drawn the symbol with equal subdivisions. There is an equal subdivision between P and N and P, but in practical this will be very thin. The layer of base will be very thin compared to emitter and collector. Okay, then this will be operated in cutoff region, saturation, active and breakdown. What is meant by cutoff is nothing but, from the word itself is very clear, cut off. See, if two are talking, if we say cut off, then what is nothing but they are not supposed to talk. So there is no current flow in cutoff region. Then what is saturation is, say I am taking class, if I take class for 45 minutes you will listen. If I take class for 1 hour you will try to listen. If I take beyond 1 hour, what will happen? Nothing will get inside your ears. So you will go to a stage called, thereafter there is no function, that is called saturation region. So usually you will have cutoff is not working because of your permission is not granted. Then permission is given, and if you are going beyond then it is called saturation. Then the third fellow is called as active region, where active region there will be change in input, there will be change in output. Okay, so that is called active. From the word itself is very clear, only in this particular region the device will be in active. Then comes your breakdown region, that is beyond saturation. Even see, if I take 1 hour, 1.5 hours, after 1 hour 30 minutes you will not listen. Okay, but if I continue for 2 more hours, let us say that I am continuing for 3rd hour, 4th hour and all, automatically what you will start? You will start saying, sir, don't need, you can stop. Even though if the staff is so strict also. Okay, even if the staff is so strict so that you will not talk, even in that case also, if the time is going beyond 2 hours, 3 hours, automatically what you will say? That is your limit. So you will reply it as, sir, leave it. So that is called breakdown. So if you increase further your value of input voltage or current, when this breakdown region is touched, the entire device will get burned. Okay, so you are supposed to operate your device only in active region, and cutoff is the region where nothing will flow. Saturation is for change in input, there won't be any change in output. I repeat, see, in cutoff region it is in reverse bias, so no current flow. In saturation, beyond which further increase will not have any change. Active region, for change in input there will be change in output. Breakdown, the condition beyond saturation where the device fails. Okay, so that is called as breakdown. Now let us move on to today's common emitter. So in common emitter, I think derivation part and all you might have seen in your theory class itself. So now this is how you have to redraw your structure. I think when you draw like this, it is little bit clear. Okay, you can see one is base, another one is collector. Base is on input side, collector is on output side, and you can see the emitter is there for both input as well as output. So when you say input, it is nothing but your base to emitter, and when you say output is between collector to emitter. Now when you measure voltage, we will measure voltage always in parallel. So input side voltage we call it as V suffix BE, that is base to emitter. Similarly, when you want to measure the voltage across output side, it has to be connected across C to E, so we call it as voltage CE, which is between collector and emitter. And now when you talk about current is in series, so you will not connect it in parallel and all. Current is in series. So current entering into a base is called as input, and current which is coming out of collector is called as output. So you put the notation as I suffix B and I suffix C. So only this 4 term is required. I repeat, with respect to voltage, you will have a voltage between base to emitter and voltage between collector to emitter, and we say current, input current we call it as IB and output current we call it as IC. Okay, first of all, when we will do two type of characteristics today. One we call it as input characteristics, another one is called as output characteristics. Input characteristics is going to tell about for change in voltage, change in input voltage, what is change in input current. I repeat, for change in input voltage, what is change in input current. When I am increasing the voltage, what about my current flow? So that is called as input current, input characteristics. To do input characteristics, output voltage should be kept at a constant value. So when you started the experiment, you are not supposed to change your voltage. Okay, once if you start doing your experiment, initially you can keep your collector voltage at any particular value. Let us assume 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. You can keep it at any voltage, but it should be kept fixed. You should not further increase or decrease this fellow. So okay, so output is kept constant. Then what you will do, you go on, you change this particular voltage and try to see what is the change in current. So you will draw the graph between input current versus input voltage. That is called as input characteristics. When you do output characteristics, what you have to do is, now you have to fix your input voltage. You should not change your input voltage. So keep it at a particular value of input voltage. Why I want to keep input voltage? Because only if there is some input, then only the device will get turned on. That is what we have started. We started that it is an active device. The flow of electron is controlled by external electric field. The external electric field is nothing but base current. So only if you give base current, then only device will get turned on. Then only we can study about the output characteristics itself. So you keep IB at a particular value, then you are not supposed to change. Okay, when you talk about output characteristics, I will say keep IB at a particular value. Whereas when I say input characteristics, I told keep the voltage at a particular value. I am not talking with respect to collector current there. I will talk only with respect to voltage. Now I am talking only with respect to current. Okay, so I will keep IB at a particular value. Then you go and change your output voltage. Try to see what is your collector current. So this is what we are going to see today. So we are going to configure your transistor in common emitter. That is the first step. Okay. So let us go to your procedure for doing the experiment. So let us start with the input characteristics first, then we will move on with output characteristics. So this is the diagram for input characteristics. Okay, so base, emitter, collector is there. Emitter is common between base and collector. Base and emitter forms the input side. Collector, emitter is forming your output side. So for input side, to vary the voltage, I am having a rheostat here. Okay, this is auto transformer, similar to auto transformer. See, if I keep at this particular portion, what is there is total resistance is coming into picture, so voltage will be minimum. When I move this and when I reach this particular instant, the full voltage is being applied. So this is just for varying the voltage. So R suffix H1 is for resistance, which is used to vary the input side voltage. Okay, to vary input side voltage. So this is RH1. Similarly, you can see here RH2. If I keep this knob at this particular portion, then the entire resistance will come into picture, so voltage will be 0. And if I go on vary this position from this end to this end, your voltage increases, and if I finally touch at this particular portion, this resistance itself is not coming into picture, so the entire voltage will come. So I repeat, R suffix H1 is for input voltage, R suffix H2 is for output voltage. So now our experiment, you have to keep, for doing input characteristics, you have to keep this fellow at a particular value, then go on increase your input side voltage and try to take the reading for your current. So current versus voltage, you will take the reading and then you will plot. Okay, so before going into experiment, let us see the procedure for doing your experiment. So first step, we are doing input characteristics. So initially both the resistance can be kept at one particular instant, then set the collector voltage. I have told when you do input characteristics, output voltage should be kept constant. So you just keep it at a value, then you start your experiment. What is our experiment is, base emitter voltage is varied by adjusting the rheostat. Note the base current reading, it will be in microamps. Then plot the VI characteristics between common emitter configuration, a graph between VBE, okay, input side voltage base to emitter voltage as x-axis and IB as y-axis. Then after taking the reading, you can, after plotting, you can press the clear button. I will show where is clear button and all. Then clear button, then you can keep your output side voltage at some other values. Let us say 1 volt I have kept, then you can keep it at 2, 3, 4 and try to see what will be your reading. Okay, so dear students, so that we let us try this in experiment. So we come to this picture. So what they told, keep it at a particular value. Okay, to vary this, what you can do is just click on this button. Your left side and right side arrow is there, no, sorry, up, down, left, right arrow mark in your keyboard. Just if you press that, you can vary. Okay, now I have kept it both in 1 ohms. That is the initial procedure told. Now what I have to do is, students, what I have to do is, you can keep it at 1 voltage. So I try to vary RH2 and keep it in 1 volt. Okay, so I have kept it in 1 volt. Okay, you don't want to take down this reading and all, because we are going to take only input characteristics. We doesn't go with output characteristics. The thing you have to notice, I have not given any input voltage. Okay, but there is some slight, and this is because we have kept it in 1 ohms. Okay, when you make this 0, okay, so now let us start the experiment. So what is our role is, you have to vary RH1 and take the reading. So now keep it here, you keep it at a particular position, then add to table, then you slightly move, repeat this, add to table. So this is nothing but I am keeping it at a various position and taking the reading. Okay, I am slowly varying the rheostat. Once I vary the rheostat, what I told, your voltage will increase. That is what we told. So you can see even in your meter, you can see it, as well as you can take the reading. See, voltage is gradually increasing. So once I keep it in maximum, so just I am go on increasing my input side, that's all. So once you have, then you can go for plot. Now you can see here, for change in input voltage, there is change in current. So all this is obtained by keeping your output as a particular value. This I have not changed, I have kept it at a particular 10 ohms, and I have done this experiment where the voltage is around 1 volt here, you can see here. So what our procedure says, first keep it at a particular value and do the experiment and try to get the graph, then vary the value as 2 volt, 3 volt, 4 volt, that you can do. Before doing that, you have to see this graph clearly, that by keeping output voltage at 1 volt, your maximum value was around 34.82 at the value of 2 volts. So input, when input is 2 volt, it was 34.82. So okay, now let us try to remember that value alone. Now let us increase my input voltage. So input voltage I am bringing into, they are saying that please keep it in 2 volt. I have kept it in 2 volt. Now again I am going to, I am keeping in 2 volt. Now again I am going to take the reading. So first let us keep it at various position. I am go on varying my input side voltage and taking my current, that's all. Okay, so we just I am repeating, I am keeping at various value of input voltage and I am taking down the reading. Now final thing is what is happening if output voltage is varied, that is what we are going to see. Okay, that is the maximum value we kept. Now you can see here, is there any change? Have you seen any change here? So same 32 point you are getting. So varying input characteristics, you have to keep only this as a constant and doesn't vary much. So this is with respect to input characteristics, students. Now let us go with output characteristics. Okay, So when you go with output characteristics, what I have told is, now in this case, see, diagram will be same, only thing, now I am going to read my output characteristics, so I have to keep input at a particular value, then I am going to vary my output voltage and try to see what is the graph. Now what is RH1? So RH1 should be kept at a particular value, say I have kept it at a particular value. Now I am going to vary each and every instant and I am going to take reading. Okay, so this reading is telling about my output characteristics. So when you might have studied theory for common emitter configuration. Common emitter configuration is used as a switch, they will call. So either you can turn on or turn off. Okay, there is nothing called amplification process and all. Only in common emitter configuration the circuit will work as a amplifier. Now you can see here, see there is a linear variation between V and I, then it becomes slightly less. For change in V, change in I is less. Then what happens is I remain constant. So when I operate in this particular region, say let us 2.5 to 10, there is no change in I. So if there is no change in I, for change in V, nothing is changing, so it is mere on off. So here it was off, here it was on. So that is why the common emitter configuration, they say it is used as a switch. I repeat, common emitter configuration is either you can turn on or turn off. At an instant you can turn on and at an instant you can turn off, but you cannot do any amplification. Amplification is not possible because this is a straight line. Okay, so you no need to buy out your there's no need to buy out anything like output characteristics, waveform and all. It is very easy. When you say common emitter you can use it as switch. Why you are saying you are using it as switch? The output characteristics, after a particular instant there won't be any change in I with respect to change in V. If there is a change between V and I, we can say it as amplification or amplifier and all. Since there is no change, it is only being used as a switch. Okay, so this is the output characteristics. So now I have kept it at a particular value, let us say input as one particular value. Now we can see what is happening if I change this input. Okay, so I am gone repeating the procedure. See, now what is the difference you have seen? The level of current has raised. See, it has come to 300. I repeat, I will repeat, you can see, just I am keeping at smaller value and then try to do, you can see what is the maximum current which you are getting. By this method, if I do, the maximum is only 50. So when I am increasing my input side, what happens? So if I am increasing the base current, the flow between this will be there. So that is why this is called an active device. See, base plays the major role. I repeat, base plays the major role with respect to output characteristics. When you want to talk about output characteristics, when you want more current to flow across your collector to emitter, when you want more current to flow across your collector to emitter, or in any application, when you want to control your output current, this output current can be controlled only with the help of base current. So if you increase this base current, automatically your output current will increase. See, you can, I will repeat it. Initially you have taken reading where you have seen it is around 4850. Now you can see here it is coming to 212. Further if I increase, it will not increase in further. So it has come to saturation. The maximum current is nothing but around 27. Are you students, are you able to understand? See here, it is clearly seen here. So the maximum current of your common emitter configuration in output characteristics purely depends upon your base current. So whatever you give from base, that is only you are able to increase your output side current. I repeat, with the help of base current only you are able to increase the collector current. That again, if you want, I will go to theory. again we will see that output characteristics where so when you want more amount of collector current, then it is purely depends upon base current. So only if you increase the base current, you can increase your collector current. So that is what we have seen from this output characteristics. So you can even see if I keep it here and then just if you keep, then only automatically you can see if this base current is around 30 microamps, you are able to current 137, okay, and it may go till 168, and if I clear it and again I will keep it at some other value, then if I plot, you can see here current has raised to 441. So from the base current alone your collector current is increasing. So this is with respect to today's class. So I think you might have understand what is input and output characteristics, okay. So if you have any doubts, you can ask me.